Hello everyone, today we are going to see exercise 1.1 sixth sum. So they have given you two numbers here. So they have given you two numbers and they're asking us to justify why these are a composite numbers. So explain why these numbers are composite numbers with a reason we are going to see. So composite numbers, as I said, it has more than two factors, so that is our criteria. So we are going to check whether it satisfies or not, so that will be your reason, right? So moving on to the sum, and yeah, so here 13 is your common number here, so I'm just removing 13 out. So if I remove 13 out, so here there is no 13, so instead of 13 I'll be writing here 1. I can't write it as 0. I'm taking the common out. So if I remove 13 out, here I'll be getting 1, and same here also I have removed 13 out, so balance here I'll be having 1. Okay, so just as it is, I'm going to multiply here. So 11 into 7, 77, and 1. So 77 plus 1 is 78. So at last 13 into 78 into 1. So I have just included here 1 because we know that both composite numbers and the prime numbers has 1 as its factor. So I'm just including here 1 so that I can satisfy this criteria which says that composite number must have more than 2 factors, right? So here these 2 factors I got from the my question itself. So this one I have just included to satisfy the criteria that a composite number has more than 2 factors, right? So now I have more than 2 factors. One is 13, 78 and 1. Okay, so since it has more than 2 factors, it is a composite number. And another number also they have given in your question, so which is yeah, here we have 5 as the common number. I'm just removing the 5 out. If I remove 5 out, here I will replace it by 1, and here also 1, right? So I will multiply all these numbers, so I'll be getting this value and plus 1. If I add it, I'll be getting 1009. I'm including 1 because to satisfy the criteria that a composite number must have more than 2 factors. So these both numbers I got from my question itself. So 1 I have just included. So since it has more than 2 factors, it is a composite number. Clear? So the main idea is a composite number must have more than 2 factors. So moving on to third sum, find the LCM and HCF by applying prime factorization method. So the given numbers are 12, 15 and 21. For HCF we will be doing separately prime factorization. Like for 12 we will be doing it separately, and for 15 and 21. Whereas in LCM we will group it and then we will be doing repeated division. In HCF these are my prime factors, so I'll be writing it separately. After that, to find the HCF, we have to first find out what is a common factor between these given three numbers. So here the common factor is 3, right? So here is also a 3, and here is also a 3, and here also. So my HCF will be 3. Okay, so whereas LCM, it is just a repeated division, so all these are my factors. So here we don't need to find any common since we are grouping it together. So after this we have to just multiply and write the answer. So this will be your LCM. Second sum, so 17, 23, 29, all these numbers are prime numbers, so it goes only in its table and 1 itself, right? So all these are nothing but prime numbers, so it is divisible only in its table, so that is itself, right? So 17 tables, 17 goes in 17th table, and 23 goes in 23rd table, and 29 also the same. So there is no common factor between 17, 23 and 29, right? So in previous sum we had 3 as common factor, but here there is no common factor, but we can't write it as 0 because the prime number is divisible by itself, and as well as it goes in one table, right? So all these numbers goes in one table, so my HCF will be 1. So it is also a common factor, right? So since there is no common factor here between these 3 numbers, so it goes in one table, so I can write it as an HCF for the given number. right? So if there is no common factor, 1 must be the HCF for the given number. So moving on to LCM, so same, it is a prime number, so nothing but we have to divide, we have to multiply all these numbers. So this will be your final answer. Clear? So moving on to last sum, so it's 8, 9 and 25. So I'll be doing separate prime factorization in terms of HCF. After this, I'll be writing the prime factors, so I have to group it. But here also there is no common factor, right? So there is no common factor here, so 1 must be the common factor. All these numbers will go in one table, right? So I'll be writing here 1. And for LCM, I'll be doing the repeated multiplication. I'll be doing repeated multiplication, so I have to multiply all these, so I'll be getting 1800. Okay, thank you.